You are preparing for humanity's biggest career pivot, moving off-world. Not in some distant future, but within your working lifetime. The companies building lunar bases are hiring now. The asteroid mining ventures are securing funding. The Mars colony planners are drafting governance structures. This isn't science fiction anymore. It's economic reality. We're about to witness the largest expansion of human civilization since we first left Africa. 3 pillars will define life beyond Earth. A space economy worth trillions. Engineering breakthroughs that solve impossible problems. And societal transformation that reshapes what it means to be human. The reality is simple. Earth is a single point of failure for our species. Every asteroid impact, supervolcanic eruption, or climate catastrophe puts all our eggs in one basket. But expansion isn't just about survival. It's about opportunity on a scale we've never seen. The space economy revolution. The first trillionaire will be an asteroid miner. That timeline is closer than you think. A single metallic asteroid contains more platinum than has ever been mined on Earth. The asteroid 16 Psyche holds an estimated $10,000 quadrillion worth of metals. Companies like Planetary Resources and Deep Space Industries aren't chasing science fiction. They're chasing the biggest resource grab in human history. But here's what most people miss about the space economy. It's not just about bringing resources back to Earth. Manufacturing in zero gravity opens possibilities that are literally impossible on our planet. Perfect spheres, ultra-pure crystals, and foam metals with properties we can't achieve under Earth's gravity. These materials will revolutionize everything from electronics to medicine. Space tourism is just the beginning. What starts as a $450,000 ride to orbit evolves into permanent orbital communities. Blue Origin and SpaceX aren't building rockets, they're building the transportation infrastructure for the first off-world economy. Think of it like building the railroads that opened the American West, except the frontier is infinite. Energy production transforms completely off-world. Solar collection in space operates 24/7 without weather interference. A single space-based solar power station could generate more energy than the largest nuclear plant. But the real game changer is helium-3 fusion. The moon's surface contains enough helium-3 to power Earth for thousands of years. One shuttle load could power the United States for a year. The supply chain extends 250 million miles from Earth to Mars. This isn't your typical logistics challenge. When a supply run takes 9 months and costs millions, you don't ship screws from Earth. You mine iron from asteroids, manufacture components in orbit, and build everything locally. This forces complete supply chain reimagination. Career opportunities multiply across every skill level. Space welders earn $200,000 annually because welding in zero gravity requires specialized training. Asteroid prospectors combine geology expertise with spacecraft operation. Orbital farmers develop closed-loop agriculture systems. Radiation shielding specialists become as essential as structural engineers. The thing is, this economy follows the same principles as every frontier economy in history. First come the resource extractors, miners and loggers. Then come the service providers, mechanics, and doctors. Finally come the luxury providers, entertainers, and artists. We're currently in Phase 1, moving rapidly toward Phase 2. What this means for you depends on your timeline. If you're under 30, you'll see the full transformation. If you're over 40, you'll see the beginning of the largest economic shift since the Industrial Revolution. Either way, ignoring this transition means missing the opportunity of multiple lifetimes. Moving forward, the engineering challenges seem impossible until you understand what we've already solved. The technology exists now. The question isn't whether we can build sustainable off-world communities. The question is how quickly we can scale the solutions and reduce the costs. That shift from impossible to inevitable is happening faster than most people realize. Engineering the impossible into reality. The radiation problem isn't theoretical. It's lethal. A trip to Mars exposes astronauts to 100 times more radiation than a chest X-ray every single day. But we've cracked this challenge using two approaches that work together. Magnetic field generators create protective bubbles around spacecraft, deflecting charged particles the same way. Earth's magnetosphere protects us. For permanent settlements, we go underground. Martian lava tubes provide natural radiation shielding equivalent to 15 feet of concrete. Life support systems represent our most elegant engineering solution. Instead of shipping air and water from Earth, we turn waste into resources. The International Space Station already recycles 93% of water from urine, humidity, and even astronaut breath. Next-generation systems close the loop completely. Human waste becomes fertilizer for food production. Carbon dioxide gets split into oxygen and carbon for 3D printing materials. Nothing gets wasted because waste doesn't exist. Only inputs for other processes. Propulsion breakthroughs cut travel time from Earth to Mars from 9 months to 3 months. Nuclear thermal rockets heat propellant to temperatures exceeding 4,500 degrees Fahrenheit, creating twice the efficiency of chemical rockets. Nuclear electric propulsion systems provide continuous acceleration for months, building up incredible speeds. NASA's testing these systems right now. The NERVA program proved nuclear rockets work in the 1,970 seconds. We're just scaling them up. But here's where engineering gets really interesting. We don't ship building materials across the solar system. We 3D print entire habitats from local materials. Martian soil contains iron oxide, rust. Heat it with hydrogen, and you get water and pure iron for construction. Lunar regolith, mixed with polymer, creates concrete stronger than what we use on Earth. Robotic systems land first, printing habitat shells before humans arrive. By the time colonists get there, their homes are waiting. Closed-loop ecosystems sustain thousands of people using principles we've perfected in extreme environments. The Biosphere 2 experiment taught us what doesn't work. Sealed systems accumulate toxins and suffer oxygen fluctuations. Modern designs use engineered biological systems. Algae bioreactors produce oxygen more efficiently than forests. Insect protein farms provide complete nutrition using minimal resources. Hydroponic systems grow vegetables using 90% less water than traditional farming. The technology exists now across every critical system. SpaceX's Raptor engines burn methane and oxygen, both producible on Mars. The Sabatier process converts atmospheric carbon dioxide into rocket fuel. Solar panels work better in space without atmospheric interference. Nuclear reactors designed for spacecraft provide reliable power regardless of solar distance. What's holding us back isn't technological capability, it's scaling and cost reduction. Building one Mars habitat costs billions. Building 1,000 costs millions each due to manufacturing economies of scale. The same pattern played out with computers, cars, and smartphones. Early adopters pay premium prices, while production systems optimize for mass manufacturing. Artificial gravity solves the bone density problem that plagues long-term space missions. Rotating habitats create centrifugal force that mimics Earth's gravity. The engineering challenge isn't creating rotation. It's building structures large enough that rotation doesn't cause motion sickness. Stanford Torus designs house 10,000 people in rotating wheels 2 miles across. O'Neill cylinders stretch 20 miles long, providing Earth-like gravity and weather systems. Redundancy engineering ensures system failures don't become death sentences. Every critical system has backups, and backups have backups. Life support systems run in parallel, with automatic switchovers. Multiple communication systems prevent isolation. Emergency shelters protect against solar storms and equipment failures. This isn't paranoia. It's survival engineering for environments that don't forgive mistakes. The breakthrough insight is that off-world engineering isn't about making Earth technology work in space. It's about designing completely new systems, optimized for space environments. Zero-gravity manufacturing produces materials impossible on Earth. Vacuum conditions enable chemical processes that require expensive equipment planet-side. Extreme temperature differentials power thermal engines more efficiently than any Earth-based system. That shift in thinking transforms impossible challenges into engineering problems with known solutions. We're not trying to recreate Earth in space. We're building something better, building societies beyond Earth. Governance challenges emerge when Earth is months away from help. A medical emergency on Mars can't wait 9 months for Earth-based consultation. A mining dispute in the asteroid belt can't be resolved by courts 250 million miles away. Off-world communities must develop autonomous decision-making systems that balance individual rights with collective survival. The reality is that traditional democratic processes break down under these conditions. Town hall meetings become impossible when communication delays stretch 20 minutes each way. Emergency decisions require immediate action, not committee deliberation. Early settlements will likely adopt modified military command structures with elected oversight, combining rapid response capability with democratic accountability. Cultural evolution accelerates in low-gravity and confined spaces. Children born on Mars develop different social norms than Earth natives. Personal space concepts shift when your entire world fits inside a few pressurized domes. Privacy becomes a luxury resource, carefully allocated and fiercely protected. Conflict resolution mechanisms must prevent minor disputes from escalating into community-threatening crises. Multi-planetary backup ensures human survival beyond any single catastrophe. But this isn't just about species preservation. It's about cultural preservation. Each off-world settlement becomes a unique experiment in human organization. Martian colonies might emphasize scientific rationalism. Asteroid mining communities might develop resource-sharing economics. Orbital habitats might create entirely new art forms adapted to zero gravity. New social structures emerge from resource scarcity and interdependence. Water becomes more precious than gold when every drop must be recycled. Energy allocation requires community consensus when solar storms can cut power for weeks. Food production involves everyone because crop failures mean starvation. These constraints force cooperation at levels Earth societies rarely achieve. Identity shifts from national to planetary citizenship. A person born on Mars has never breathed unfiltered air or felt rain. Their loyalty isn't to any Earth nation, but to their survival community. Second-generation colonists develop distinctly Martian perspectives on everything from architecture to philosophy. Within decades, we'll see the emergence of genuinely alien human cultures. Communication delays force local decision-making autonomy that reshapes political structures. Mars governors can't consult Earth leadership during emergencies. Asteroid belt miners must resolve disputes locally or face economic collapse. This communication lag creates natural federalism, local autonomy, with periodic coordination when bandwidth allows. But here's the counterintuitive part. Resource scarcity often produces more egalitarian societies than resource abundance. When everyone's survival depends on the community's success, traditional class distinctions become counterproductive. The most valuable people aren't those with the most money, but those with the most essential skills. Doctors, engineers, and food production specialists become natural leaders. Legal systems must address crimes that don't exist on Earth. What happens when someone sabotages life support systems? How do you handle theft when replacement parts cost millions and take years to deliver? Murder becomes not just homicide, but potentially community genocide if the victim possessed critical knowledge. Marriage and family structures adapt to small population genetics and communal child-rearing necessities. Genetic diversity becomes a community resource, requiring careful management. Children belong not just to parents, but to the entire settlement's future. Educational systems must produce polymath generalists rather than narrow specialists. The thing is, these aren't distant theoretical problems. Companies planning Mars settlements are drafting these governance frameworks now. The Artemis Accords establish basic principles for lunar activities. Private space ventures are creating corporate structures that will evolve into colonial governments. What emerges won't be Earth societies transplanted to new worlds. They'll be genuinely new forms of human organization, adapted to environments that demand cooperation for survival, while fostering innovation through necessity. The timeline and your role. Moon bases operational by 2035. That's the stepping stone economy that makes everything else possible. NASA's Artemis program isn't just about planting flags. It's about establishing permanent lunar infrastructure that serves as humanity's first off-world industrial base. The moon's low gravity makes it the perfect launch platform for deeper space missions. Shipping materials from lunar surface to Mars orbit costs 20 times less than shipping from Earth. The lunar economy starts with water extraction from polar ice deposits. Water isn't just for drinking. It splits into hydrogen and oxygen for rocket fuel. Every kilogram of water on the moon eliminates the need to ship fuel from Earth at $10,000 per kilogram. Lunar mining operations will extract rare earth metals, essential for electronics manufacturing. The moon's lack of atmosphere makes it ideal for telescope construction and space-based solar power assembly. Mars colonies by 2050 represent permanent human presence beyond Earth's gravitational influence. SpaceX's timeline puts the first crewed Mars landing around 2029, with permanent settlement infrastructure following within 2 decades. But Mars isn't just a backup planet. It's humanity's first truly independent world. Martian colonies will develop their own economies, cultures, and eventually their own technologies that surpass Earth capabilities. The Martian advantage comes from reduced gravity and abundant resources. Mars has water ice, carbon dioxide atmosphere, and iron-rich soil. Martian manufactured goods will eventually compete with Earth products because shipping costs favor local production. Within your lifetime, Mars will transition from scientific outpost to economic competitor. Asteroid belt mining by 2060 triggers the resource revolution that transforms both Earth and space economies. The asteroid belt contains more accessible metals than Earth's crust. A single metallic asteroid provides more platinum than humanity has ever mined. But asteroid mining isn't about crashing the Earth metals market. It's about supplying the growing space economy with construction materials. Asteroid mining operations become the foundation of interplanetary commerce. Raw materials mined in the belt supply Mars colonies, lunar bases, and orbital habitats. The economics favor space-to-space commerce over shipping everything from Earth. Asteroid miners become the oil barons of the solar system, controlling the resources that power human expansion. Skills that translate directly include engineering disciplines adapted for space environments. Mechanical engineers design systems that work in vacuum and extreme temperatures. Chemical engineers develop closed-loop life support systems. Civil engineers plan habitats that withstand radiation and micrometeorite impacts. But the opportunities extend far beyond traditional engineering roles. Medical professionals become essential for long-duration space missions and permanent settlements. Space medicine requires expertise in radiation effects, bone density loss, and psychological health in confined environments. Surgeons must operate in zero gravity, using robotic assistance. Mental health specialists help communities cope with isolation and confinement stress. Agricultural specialists develop food production systems for environments without soil, seasons, or natural weather patterns. Space farmers combine hydroponics expertise with closed-loop ecosystem design. They're not just growing food. They're maintaining the biological systems that keep communities alive. Every crop failure becomes a potential survival crisis. Psychology and sociology expertise becomes critical for community stability. Small, isolated groups face unique challenges that Earth-based communities never encounter. Conflict resolution specialists prevent minor disputes from escalating into community-threatening crises. Social organizers design governance systems that balance individual rights with collective survival needs. Investment opportunities emerge across space infrastructure development. Launch service companies like SpaceX and Blue Origin represent just the beginning. Satellite manufacturing, space-based solar power, orbital construction, and asteroid mining ventures all require massive capital investment. Early investors in space infrastructure companies position themselves for returns that could dwarf traditional Earth-based investments. But here's what most people miss about space investment timing. The biggest returns come from supporting infrastructure, not headline-grabbing missions. Companies that manufacture space-rated electronics, develop closed-loop life support systems, or create radiation shielding materials will service every space venture. These picks and shovels investments often outperform the gold miners themselves. How to position yourself in the off-world economy depends on your current skills and timeline. If you're early in your career, consider aerospace engineering, space medicine, or closed-loop agriculture systems. If you're established professionally, look for ways your expertise applies to space environments. Lawyers will draft interplanetary contracts. Accountants will manage multi-world supply chains. Teachers will educate the first generation of spaceborne humans. The key insight is cross-functional resilience. Space environments demand generalists who can adapt their expertise to completely new challenges. A mechanical engineer might also need medical training for emergency situations. A doctor might need to understand hydroponic systems when food production fails. The most valuable space colonists will be those who combine deep expertise in one area with broad competency across multiple disciplines. The strategic reality check. This transition is inevitable. The question isn't whether humanity expands into space, but how quickly and who participates. The driving forces are too powerful to ignore. Resource scarcity on Earth, technological capability reaching critical mass, and economic incentives worth trillions of dollars. Companies and nations that ignore space development will find themselves competing for scraps while others control entire worlds. Earth remains home base for the foreseeable future, but opportunities multiply exponentially beyond it. The space economy won't replace Earth's economy. It will dwarf it. When asteroid mining provides unlimited raw materials and space manufacturing produces impossible materials, Earth-based industries must adapt or become obsolete. The choice isn't between Earth and space careers, it's between participating in expansion or watching from the sidelines. Cross-functional resilience applies directly to interplanetary careers because space environments punish narrow specialization. The most successful space professionals will be those who combine technical expertise with adaptability, leadership skills with hands-on capability, and Earth experience with space-specific knowledge. Traditional career paths become launching points for space adaptations, rather than final destinations. The biggest risk isn't technical failure or economic collapse. It's ignoring this shift entirely. Companies that dismissed the internet in 1995 never recovered their market position. Nations that missed the Industrial Revolution remained economically dependent for centuries. Individuals who ignore space development will find themselves competing for increasingly limited Earth-based opportunities, while others build wealth and careers across the solar system. But here's the strategic reality most analysis misses. You don't need to move to Mars to benefit from space expansion. Earth-based companies will service space operations for decades. Earth-based investors will fund space ventures. Earth-based professionals will design systems for space implementation. The space economy creates opportunities both on and off Earth, but only for those who understand and prepare for the transition. Space expansion represents economic opportunity on a scale humanity has never seen, not just scientific exploration. The first trillionaires will emerge from asteroid mining, space manufacturing, and interplanetary commerce. Your career positioning today determines whether you participate in this wealth creation or watch others capture it. If you found this analysis useful for planning your future strategy, subscribe for more trend breakdowns that help you stay ahead of massive shifts. Tell me in the comments, which space career opportunity interests you most? Lunar mining, Mars agriculture, or asteroid prospecting?